pH measurement of pure water. Many industrial sectors, like vaccinations and pharmaceutical companies, food and beverages production, and power generation, require pure water for their day-to-day laboratory testing and process activities. pH of pure water correlates the efficiency of water purification systems, the amount of soluble trace minerals present in it, and its ability to corrode metals. The pH of water is expected to be pH 7.00 at 25 degrees Celsius. ASTM is the American Society for Testing and Materials. ASTM D1293 method describes the pH measurement of water samples. The precautions to be taken for pH measurement in low ionic water samples are described in ASTM D5464 method. It is important to note, measuring pH of pure water is not easy. There are challenges when you try to measure pH of pure water. First, reading fluctuation and long response time for the measurement. Second, contamination of sample. Third, inaccurate results. Pure water samples are low in both hydrogen ions and conducting ions. The low ionic concentration of pure water causes a large difference in ionic strength between the reference electrolyte and the sample. This prevents a stable liquid junction potential in the pH electrode system and causes a long stabilization time. Further, the low ionic concentration makes pure water susceptible to ingress of carbon dioxide from air. This absorbed atmospheric carbon dioxide becomes carbonic acid in the sample. Therefore, the pH value changes, and wrong results may be obtained. Inaccurate results can also occur due to the lack of sensitivity of the high-resistance glass membrane for hydrogen ions in low ionic samples. Thus, the pH value gets recorded without reaching an equilibrium, and therefore, the pH measurement accuracy gets compromised. Mettler Toledo offers a specialist Sensor InLab Pure Pro ISM for pH measurement in low ionic and pure water samples. This sensor has a pH-sensitive membrane made of LOT glass, which has a low resistance, and it has a spherical shape to offer a large sample interaction surface. This results in fast response time and measurement of even very small changes in hydrogen ion activity. The sensor has a glass sleeve that allows a steady outflow of the electrolyte. 1 molar instead of 3 molar potassium chloride electrolyte is used to reduce liquid junction potential and ensure highly accurate pH measurement. This sensor has an inbuilt temperature probe. Thanks to the intelligent sensor management, the electrode's name, serial number, and calibration data are stored in the sensor itself. Now we will see the calibration of the pH electrode and pH measurement in the deionized water. For the pH measurement in pure water, we need a pH meter with U-Mix magnetic stirrer, U-Place electrode holder, InLab Pure Pro ISM sensor, and multi-pin cable, buffer solutions, glass beakers for samples, a flow cell, maintenance solutions. The calibration and the measurements are carried out with automatic endpoint type and standard endpoint criterion. Use an electrode calibrated using standard buffer solutions pH 4.01, pH 7.00, and pH 9.21, such as to bracket the expected measurement value. As explained before, pure water samples are vulnerable to absorption of atmospheric carbon dioxide. Low ionic water samples with conductivity less than 100 microsiemens per centimeter should be ideally measured in a closed system, protected from ingress of air. If we have a direct source of purified water, it is recommended using a flow cell as it helps to maintain the sample integrity. In case of water samples which are supplied in the containers and do not have a direct source, it is recommended to degas the sample before the measurement. Some tips to get accurate and precise results. Take maximum care to avoid any exposure to air and atmospheric carbon dioxide, even during sample handling. If possible, measure the sample directly from the source. Use flow cell for the water samples, which have conductivity less than 100 microsiemens per centimeter. Using glass containers is recommended, since air can diffuse through plastic. Test the samples as soon as possible after collection to minimize temperature changes, sample aeration, and contact time with the sample container. Make sure that all containers and tubings are well rinsed with pure water before use to avoid cross-contamination. Always use fresh buffers for the electrode calibration. Regular maintenance is very important for prolonging the life of pH electrode. The electrolyte needs to be refilled regularly. Store the electrode in in-lab storage solution. Prior usage, keep it in pure water for 1 minute and rinse it well. Make a proper choice of electrode for your application to achieve better accuracy.